there been studies that found a naturalistic path to homochirality?
Um, there are studies that have suggested ways in which homochirality could emerge, but none of those potential pathways actually look like they would be viable in a real life, origin of life scenario. And part of the problem is that when you have a chemical reaction taking place that generates a chemical product that is going to display chirality, what ends up happening is you typically get a 50-50 mixture of the left-handed and the right-handed form. And this is essentially the main problem confronting the origin of life, because you've got to now come up with some kind of chemical or physical process that's going to generate, again, 100% chiral enrichment. And nobody knows how that could possibly happen. Again, there have been some chemical solutions to this problem that have been proposed, but none of them look like they would be viable on the early Earth. There have been physical mechanisms that have been proposed. None of those look like they would really be viable on the early Earth. And there's even been astronomical mechanisms that have been proposed that, again, don't look like they're viable. And so this is really one of the most significant problems confronting the origin of life is really the homochirality problem. The last time I was at an origin of life research conference, people acknowledged that we don't have an explanation for homochirality, and really just almost literally set the problem on the back burner and just progressed as if that didn't even matter. They just simply acknowledged it and ignored the problem, which is interesting because 15 years prior to that, when I was attending origin of life research conferences, this was a major theme in those conferences, is how do we explain homochirality? And there was an ongoing recognition that everything that we're trying to do to explain homochirality turns out to be a dead end, turns out to be deeply problematic. And so what I saw happening is that the problem was essentially such a chronic problem that it became essentially part of the backdrop, or part of the noise, if you will, at these conferences, where people no longer were even working on the problem. It was essentially kind of stalemated. They felt like as if they were stalemated, and again, we're just setting the problem on the back burner and progressing, as if the problem doesn't exist.
It seems recently, perhaps in the last couple of years, I saw a newspaper article referring to some experiment that said they had been able to take a mixture from racemic to homochiral molecules to a certain percentage. I don't recall, maybe 10% or so, I think it was. Has that been fruitful, that line of research?
Well, yeah, there are, in other words, the best that people can typically do, whether it's a chemical mechanism or a physical mechanism or some kind of astronomical mechanism, is a slight chiral enrichment of maybe 10% or 15% at the most. And while that is interesting, it's irrelevant to the origin of life, because you have to then figure out a way to amplify that 15% to essentially 100%. And even if you do have mechanisms that can get you theoretically to 100%, it's a transient state. You arrive at 100%, and then very quickly that system will decay back to about 80% chiral enrichment. So even when you can theoretically generate 100% chiral enrichment, it's not a final state. It really is just transient. It's ephemeral. It only lasts for a short period of time.
Well, getting back to the origins of life in general, it seems the first cell would have had to have a cell membrane of some sort in order to keep the good stuff in and the bad stuff out. And in your study of cell membranes, are they simple?
No, cell membranes are incredibly complex systems that display remarkable organization at several different hierarchical levels with respect to membrane structure. They're very sophisticated, highly organized systems, and impossible to conceive how membranes could originate under the conditions of the early Earth. Now, the compounds that make up cell membranes have very interesting properties where they're called amphiphilic, where part of the molecule will dissolve in water, part won't dissolve in water. And those kind of molecules, when you add them into a water solution, will spontaneously assemble into these aggregates. And so you can get certain of those kind of amphiphilic compounds to form bilayer structures when you just add them to water. But the problem is that these structures are nothing like what you see cell membranes like. And in order to get those bilayer structures to be much more like what you see in the cell membrane requires exacting environmental conditions and exacting chemical structures and exacting chemical compositions. You have to have a very precisely fine-tuned system in order to get bilayer-like structures to form that would be truly reminiscent of what you see in cell membranes. And that to me is something that defies an evolutionary explanation, because you're never going to have those precise exacting conditions on the early Earth.
Do they have a general outline or model for how the first cell membranes would have formed? Is that what you just discussed?
Yeah. And so there is kind of an outline for how that could have emerged, where people argue, well, first of all, you would form simple amphiphilic compounds that would form aggregates that under certain conditions could form bilayer structures. And eventually over time, these simple primitive membranes would evolve to form the more complex membranes that we see in biological systems today. So there is a general outline that people have proposed, but literally every step of the process requires highly precise, exacting conditions. And what you need to go from, or the set of conditions you need to go to transition from one stage in that process to the next, actually don't match each other. And so you as soon as you need to transition to the next stage, it requires a completely different set of conditions in order to support that particular stage in membrane evolution. And so the scenario that you would need in actuality is impossible to envision how you could ever find an environment like that on the early Earth. Perhaps the big kicker is, in order for these lipids to form, or these amphiphilic materials to form bilayer-like structures that again would approximate a cell membrane, requires essentially highly purified water environments. Any kind of minerals dissolved in that water will essentially frustrate the process of membrane evolution. And it's impossible to envision where you would find highly pure water under the conditions of the early Earth.
How do the origin of life scientists believe that, I assume RNA before DNA is the standard paradigm? How do they think that RNA began? Doesn't it suffer from many of the same problems as DNA origins?
Yeah, well, what's going on with the RNA idea is that when we look at contemporary biochemical systems, which consist of essentially what would be called a DNA protein world, you have essentially the information in DNA that specifies the production of proteins. But in order to make those proteins, it requires the existence of proteins. And in order for DNA to even replicate itself, requires proteins. And so what you have is this interdependent system where DNA is dependent upon proteins and proteins are dependent upon DNA. So it's what is called a chicken and egg type of system. And so this is the chicken and egg paradox facing the origin of life, is you cannot envision how you could have a world where DNA would evolve and then proteins later because of that interdependency, or you can't envision how you could have proteins evolve first and then DNA secondarily because, again, of the interdependency. And so people have thought, well, maybe a solution to that problem would be to propose a biochemistry that would be a preamble to the contemporary biochemistry. And so one idea is that maybe the very first biochemistry was built around RNA as opposed to DNA and proteins, where RNA would serve, in a sense, both as the the molecule that could store information, but also as a molecule that could serve the catalytic roles, the functional roles that proteins could play. So you're kind of imbuing in RNA both information storage and functionality that is partitioned into DNA and proteins in contemporary biochemistry. And so I've heard many origin of life researchers say that there has to be an RNA world because if you didn't have an RNA world, you would wind up with this chicken and egg paradox. But yet the RNA world problem, the RNA world scenario is just riddled with some very serious problems. One of them is the homochirality problem, because in order for RNA to form, even RNA chains from RNA building blocks, you have to have strict homochirality. So here's where the homochirality problem rears its ugly head for chemical evolution. But there's other problems, like how do you get the RNA building blocks to begin with? This is a major problem. Or once you get them, how do they actually assemble into RNA molecules? That's another very serious problem confronting, the RNA world hypothesis.
So do they have a proposed mechanism or pathway to reach chemical evolution to RNA?
There are ideas that have been proposed, and there are experiments that have been done in the lab that seemingly, in principle, justify those proposals. But what is really exposed with the RNA world approach is this, that the work done in the laboratory to validate the different aspects of the RNA world is done under highly controlled, chemically pristine conditions where the researchers are controlling the solvents, they're controlling the chemical reactants, they're adding the right concentrations with the right order of addition, they're stopping the reaction at the just right point in time. In other words, the researchers are playing an active and central role in the success of the chemistry in the laboratory. And when you try to translate those processes to the conditions of the early Earth, you quickly realize that if there's not a chemist present, it's unlikely that the chemistry is ever going to really take place under the conditions of the early Earth. And so, ironically, work done to try to validate the RNA world hypothesis is actually showing that intelligent agency is a vital part of any kind of a process where molecules are transformed into more complex molecules in support of some kind of origin of life. So ironically, work in prebiotic chemistry and specifically on the RNA world have provided evidence that a mind is required to convert molecules into the very first cells.
So what came first, the cell membrane, the method for reproduction so that the first proto-cells could continue onward and make more, or otherwise you just end at the first cell, or metabolism to allow them to be alive in the first place? Which of the cell membrane, reproduction, or metabolism, which came first in this step-by-step process?
Well, in effect, what you're pointing out is the idea that really for life to exist in its bare, simple, minimal form really requires four things. One is a membrane of some sort to form a boundary separating the interior environment from the exterior environment. You have to have some means of harvesting energy, which would be metabolism. You'd have to have some means to replicate DNA, and then you'd have to have some means to make proteins that would carry out the different activities. And each one of these is absolutely indispensable. You cannot have a living system if you have three of those four systems. You have to have all of them. So in effect, life is really irreducibly complex, to borrow Michael Behes' concept.
I spoke to him 2 weeks ago, so I heard quite a bit about that.
Yeah, and so Michael Behe is using the concept of irreducible complexity with respect to an individual biochemical system. But here, the concept of irreducible complexity is being applied to the cell in its totality. And so how do you explain through chemical evolution the emergence of even the simplest cell in a stepwise manner? You've got to have core processes existing simultaneously, and not only existing simultaneously, but actually integrated with each other, working collaboratively for life to be possible. And I just don't know how you would account for that in any kind of original life scenario. At least at this point, nothing I've seen proposed can really explain, how you can go from molecules to this irreducibly complex system that, even in its minimal form, is astoundingly complex.
In minimal form, how many proteins we talking about, would you say?
Minimally, it would be probably in the neighborhood of about 500 different types of proteins. And that would be for an entity that would be recognized as being a life form, but that entity would actually not be able to exist independently in the environment. For an organism to exist independently in the environment, minimally you're looking at somewhere on the order of about 1,500 different proteins, different types of proteins.
So you're saying the simpler version would have to be some kind of symbiotic life, and the more complex version, the 1,500, would be a life that could exist on its own, which obviously the first life would have had to have been more like the 1,500 than the 500.
Exactly. Yes, exactly.
Wow. So we've kind of hinted around at this and hit at this throughout this entire interview, but do you see evidence for design in the cell's operation?
Oh yes. To me, the design that we see inside the cell is absolutely astounding. And one of the best ways, I think, to really envision uh, the nature of that design is to think about the old watchmaker argument of William Paley, where Paley, argued that a watch requires a watchmaker because a watch has certain attributes that reflect the work of a mind. And in Paley's day, when he surveyed biological systems, he argued that those systems also have the same kind of properties that a watch has, and therefore look like they too require the work of a mind. And so if we take that idea and apply it to biochemical systems, what we note is that the defining features of biochemistry are identical to the defining features that we would recognize as markers for the work of human designers. In other words, when we design or create or invent a system or an object or a device, there's just certain properties that reflect, again, the artificiality imposed upon, imposed by a human mind. And we see those same identical characteristics that define biochemistry. And so using kind of the watchmaker reasoning, it would make sense that biochemistry too is the work of a mind. But in many instances, we see biochemical systems that are absolutely eerie in terms of their similarity to man-made or human designs. So one example that I find astounding is that the biochemical operations that take place when the cell's machinery manipulates DNA, whether for DNA replication or DNA repair, or for processes like transcription, are literally computer operations. And the machinery that manipulates the DNA are literally functioning as biochemical Turing machines. And a Turing machine is an abstract machine that forms the basis for how to think about computer operations. And so literally what we're looking at when DNA is manipulated by the cell's machinery are these very complex computer operations. And in fact, the similarity is so stark that it has inspired a new area of nanotechnology called DNA computing, where scientists are trying to build literally computers, wet computers in the lab from DNA and the proteins that manipulate DNA. And so we know from our experience that computers must come from a mind that conceived them, that designed them, that then built them. And so when we see computers that are operating inside the cell, it's rational to think that they too came from the work of a mind.
So it's more of an argument from analogy, not an argument from ignorance.
Yes.
Okay.
Yeah, it's definitely not a God of the gaps argument.
Yeah, because obviously that one's an example of argument from ignorance, which is a not informal logical fallacy. And so it should certainly be avoided by all Christians, apologists especially, and Christians in general, and all people for that matter. And I think if people are curious to see about the molecular machines, go to Wikipedia and type in molecular machines. They have a list of 20 or so right there, many with animations. They can see these machines for themselves and ask themselves, does this look like something that happened the same way rivers change course and coming down the hills, or this is like something that was designed, not just happened in essence. Obviously, there's certain preferential chemical pathways that would lead to certain things happening, but in general, molecular machines certainly look a lot more designed than not designed. Specifically for the class on scientific apologetics I'm teaching, what would you say, tell my students is the biggest scientific apologetics challenge today?
Well, to me, when you're dealing with any kind of argument that involves design, whether it's design at the cosmic level or at the Earth, when you look at Earth design, or design in biological or biochemical systems, to me, the two rejoinders that you commonly see would be, well, what about the so-called bad designs that we see, right? That's
teleology.
Yes, and so that is a perennial challenge that I think there's good responses to, but that is indeed a perennial challenge that I see that has to be actively engaged. And the second challenge would be, in effect, the problem of natural evil, which in some respects is related to the bad design argument. But here, with respect to the problem of natural evil, it is, well, if God is responsible for creating a world, a universe that's designed, or a world that's designed, or a living realm that's designed, then why is there so much pain and suffering that we see? Why is nature red in tooth and claw?
Words, yeah.
Yes, yeah. And so, in other words, again, it's this idea of teleology, but here it's formulated in such a way that it carries this emotional punch to it. Mm. So to me, if you're involved in scientific apologetics, there's great design arguments that we can make, but you've got to be prepared to respond to what about the bad designs, and what about really the pain and the suffering that we see in the world. That seems to be, for many people, to be incompatible with a biblical concept of God. So we need to be able to engage, those two challenges.
I think so. And I think in the problem of evil question, that it's really good to ask questions, because many times what's masquerading as a question of evidence or logic or compatibility is some personal hurt within their own life of something that happened. And if you give a logical answer to something that pains them in their heart, you're not connecting in a way that's going to work for them. So recognizing that people are still humans and have needs and feelings and emotions, and giving the answer on the correct level, I think is key to that.
Well, the thing is, the problem of evil is a really difficult and challenging issue to address. There's not a simple pat answer, but what I like about when that objection is raised is it's essentially a theological objection. Mm. So you've moved from a discussion of science to a discussion of theology.
Yeah, what is God like?
Yes, and this is a really great opportunity now to move people towards the gospel. The problem of evil, if you begin to engage it, really invites a presentation of the gospel, because ultimately the solution to the problem of evil is really found in the person of Christ. So when we get to the problem of evil, that's where the real ministry opportunities actually happen. So it's not something that you want to shy away from, but it really is something that you want to lean into, but recognize that it's a very messy endeavor when you lean into the problem of evil. You're never going to walk out of there feeling like you've done a good job really answering people, but you are having significant conversations with people that are getting you to the heart of the gospel.
Doing what David Geisler likes to call moving them one step closer to the cross.
Yes.
For once again, relating back to my class and others who will be watching this eventually on YouTube, any advice for Christians entering scientific apologetics?
I would say that if you really are serious about getting into scientific apologetics, and there's very good reasons to do that, by the way, because given that we live in a world that's becoming increasingly secular, where people have enormous amount of respect for science and for the technology that is derived from science, to be able to use science to build a bridge to the gospel is really a very powerful tool, but it requires that you do your homework. That you know, if you're really serious about doing scientific apologetics as a full-time ministry focus, I would almost recommend getting advanced degrees in some area of science and then go into the apologetics arena secondarily. But if you don't have those particular aspirations, there's nothing that replaces just rolling up your sleeve and doing the homework. And that involves not only reading what Christian apologists write, but actually reading what people who are skeptics are writing as well. And then just even spending time in general, just immersing yourself in science, just reading and understanding the principles. Because a lot of times when you present arguments, when it comes to, you know, scientific arguments for God's existence or the reliability of Scripture, the arguments you're presenting are, if you will, kind of like the tip of the iceberg. And it looks like all you're seeing is the iceberg's tip. And it's like, wow, that's such a powerful argument. But beneath the surface is this massive piece of ice. And many times what happens is if you engage people that are really adept in the science, they're going to be aware of all kinds of stuff that you may not be aware of that then constitute objections to the argument that you're presenting. So it's very important that you develop a sense for what it looks like beneath the surface. What is the other science that might actually be marshaled to as a rejoinder to the argument that you're making? And so just spending the time reading science just for the sake of reading science really equips you to be more familiar with what's underneath the surface and helps you sometimes anticipate, you know, the rebuttals that might be made to the arguments that are pretty popular and commonly used by Christian apologists.
Yeah, I would say from my own experience, not being a scientist, but somebody who has a lifelong love of science, that God will give you a greater desire to understand what we know, what we don't know, and what science has to say about many issues, simply because your desire is to serve in the right way.
Mm-hmm.
Well, Fuzz, it's been a fascinating discussion. We've discussed many of the origin of life issues and decided that the naturalistic explanations are perhaps lacking in many areas, and they have a lot of work to do. We've discussed the issue of scientific apologetics in general. I want to thank you very much for taking time out of your busy schedule to be with us and discuss these issues.
Don, it was a pleasure. Thanks for thinking of me.
Well, I'll think of you next time I listen to B.B. King.
There we go.
All right.